Okay, this is Channing Pan, and it's a video for EC 6303 Homework 8, Question 2. Okay, let's come to this question. And we have Poisson process, that's N, with a parameter lambda. And we have Pn, and we define the number of random points arriving between the time t1 and t2 and the interval equals to k. The probability for this number equals to k, that's in the E with the power of minus lambda t2 minus t1, and that's in lambda t2 minus t1 the power of k, and then the k factorial over the k factorial. Okay, we have now a new stochastic process, the next t, when the that's n equals to 1 if the number n is odd between the interval minus 0 to t, and the xt equals to minus 1 if the n is even between the interval 0 to t. Okay, and that's the graph of the of xt. So we have four sub-questions. In the first, we should find the probability for xt equals to 1, and the second is we should find expectation for xt, and we should find the rt1 and t2, and the last we should find xt. So let's come to the solution. And okay, the first sub-question, we should find the probability for xt equals to 1. Okay, we knew that for xt equals to 1, that's equals to the probability that n is odd in the interval from 0 to t. Okay, since we have n equals to odd, so n is like 1, 3, 5, 7. So let's write it down like in the sum, like the sum. Okay, that's e minus lambda t, because we have a interval 0 to t, so t1 t2 minus t1 equals to t, so that's an e with the power of minus lambda t, and the lambda t with the power of k over the k's factorial. Okay, let's put it in expansion. That's an e minus lambda t. Okay, it has nothing to do with this one. So that's an lambda t. That's the k equals to 1, and k equals to 3, k equals to 5, and k equals to 7. Like that's an infinity. That's an infinity sum. So let's do the Taylor expansion. Okay, between lambda t is some kind of close to 0, we do the Taylor expansion in the location of 0, the lambda t equals to 0. So that's in a k from 0 to infinity, the lambda t with the power of k over the factorial of k. Okay, we do the Taylor expansion of e with the power of minus lambda t again. So that's a lambda t. That's just the lambda t. We do the alternative like minus lambda t. So we put the minus 1 separately, and that's minus 1 with the power of k. Okay, we that's in 1, that's 2, 1 minus 2, we have e with the power of e powers lambda t minus e powers minus lambda t. So like we have only lambda t, and k equals to 3, k equals to 5. We knew that. We look at the both, and we knew that they were some kind of similar. Okay, so the star would equals to 1 over 2 and 1 minus e powers minus 2 lambda t. Okay. So the probability for xt that equals to this. Okay. And we knew that the expectation for xt, that would be the probability that 1 multiplies with the probability that xt equals to 1 minus plus minus 1 with minus 1 multiplies with the probability that xt equals to minus 1. Okay, that's quite similar with the sub-question A, and we have the final solution that the expectation for xt equals to minus e with the power of minus 2 lambda t. Okay, the third sub-question, we should find r, t1, t2. So for t2 larger than t1, that's an e xt1 minus multiplies xt2. So it's quite similar with the sub-question B, and since we have the xt1, xt2 equals to 1, which means that we have xt1, xt n equals to nt1 equals to 1, and nt2 equals to 2 to 1, or they both are minus 1, which means that the k equals to even. And similarly, that would be k equals to odd. So that's quite similar with the sub-question B. So the final result would be e minus 2 lambda t2 and minus t1. So let's reconsider that t1 larger than t2, and we consider it, and that would rt1 to do would be e with the power of minus 2 lambda with the absolute value of t1 minus t2. So according to both the above and xt would be WSS. So that's the final solution to this question. Thank you.